So once MiniMax H3 training actually starts, I checked VRAM usage. It is about 14 gigabytes. You read that, right? Just the Inter-8 text encoder alone has about 26 gigabytes. But if you pull blocks to swap to 48, actual training VRAM usage stays around 14 gigabytes. So a 16 gigabytes VRAM GPU can indeed train MiniMax H3. Of course, that means it can train, not that it is fast. The model didn't shrink. Many blocks just moved to system RAM, saving VRAM, slowing things down, and using more system RAM, and relying more on GPU to memory data transfer. No magic here, just trading space for time. But what is truly absurd is later organizing tutorials, I found the real pitfalls people hit might not actually be VRAM, but frame bucketing. But what exactly does real bucketing split? Many are used to training image LoRAs. Pick a resolution, toss it in the dataset, and start. With video, you instinctively set it up the same way, but that fails. Images teach the model to view a single photo. Videos teach it to understand short time segments. So frames must be bucketed by size, and time must also be bucketed by length. This time, I used the 133 and 65 needle barrels. The first part is for images. Videos won't go in that bucket. A 48 frame video goes into the 33 frame bucket, not forced into the 65 frame one. If it doesn't even reach 33 frames per SE count, it might just be discarded. During training, the MiniMax H3 preprocesses video at 24 FPS. 33 FPS is about 1.4 seconds. 65 is near 2.7. Think about it. If most actions in the dataset occur in the latter half, but if you set 33 frames and always start from the beginning, that is what the model learns. It likely only sees the short build-up before motion starts. The GPU runs hard, but learns no movement. So longer clips aren't always better, and copying others' params won't work. First, check your footage's frame count and where action happens, then decide on 33, 65, or a longer bucket. We've also built a video preprocessing tool in the DeepPavlov toolbox, which can scan the entire folder first to show the resolution of each video, frame rate, total frames, and duration distribution. You can also batch process high frame rate footage. Check the data before setting up frame bucketing, which matters way more than tweaking an extra zero in the learning rate. Returning to model loading, the MiniMax H3 uses convey format files, including the diffusion model, video VAE, audio VAE, and text encoders. All of them must be configured correctly. Even if your footage has no audio, don't leave the audio VAE path empty. One nice thing this time is, you can directly use the quantization model training LoRa for Intel 8 convert. The interface's diffusion data type to keep the checkpoint's native quantization. You don't need to dequantize the base model before loading it into VRAM. A quantized base model can only be used to train adapters like LoRa. For full fine-tuning, you still need a non-quantized model. Don't force it, or you'll melt your GPU instead of training. There is a counterintuitive part during the caching phase, that about 26 gigabytes in a text encoder, thanks to Convey's dynamic RAM management, can compute embeddings, even on GPUs with limited VRAM. After caching, it might just stay in system RAM. Then system RAM crashes, right when training starts. Don't panic, just run the cache generation separately first. Close DeepPavlov, reopen it, then reuse the cache for training, but don't blindly trust the cache. If you've changed videos or annotations, the cache needs to be regenerated. Old answers for new questions are just unreliable. There's one hard rule. Micro batch size must be 1. Need a larger effective batch. Increase gradient accumulation. Just fill in 2 and 4. No surprises. Only errors. This time, I started with 512 resolution, 33mm, and 65mm needles. Micro batch size 1. Gradient accumulation 2. Then increase the blocks to swap to 48. Get the entire pipeline running. That is a working start, not a perfect answer. Also, if your video has audio, H3 will take the audio for training and then resample to 32 kHz. It can learn the dialogue in your source material, background music, ambient noise. It won't ignore even strange sounds that slipped in from nowhere. So before training, you must also audit the data with your ears. Currently, this setup supports text-to-image and text-to-video training. Reference image, but video editing, image-to-video, and first-to-last frame conditional training aren't done yet. You can train on images alone, but feeding too many images may gradually weaken the model's grasp of motion. Honestly, MiniMax H3 still lacks standard answers for quite a few things. Training gradually removes the distillation adapter. During inference, you might need to set CFG shift to 8 or 12, depending on whether you prioritize details or larger structures and motion. Following the shift, we add a new option. Image shift only affects single frames. Videos still use the main shift upstream, recommending images start from 1 or slightly above. If all your data consists of videos, you can basically ignore this option. Quick note: the new version will now actively attempt to release the VA and text encoders after caching completes, but upstream says some machines can only free part of the memory. So if memory won't drop, stick to the old way, cache first, restart, then use defy purge to reuse a U cache for training. There is also one spot where it is easy to pick wrong: an experimental H3 training and the distillation adapter are out now. We added path selection to the interface. It loads the base model before training. I also added a feature I needed: checkpoint resume. Before, if training stopped, I had to check output timestamps. To find a global step, the training page now auto-detects existing sessions. Select the folder for that training session, and you can resume training. There's a small pitfall here. You must select the training session directory that contains latest, not the latest file itself, nor the global step subfolder. I've organized all needed models and packages and uploaded them to the cloud drive. Veterans, don't just overwrite old files with new ones. Because the underlying environment has been updated this time, you must download the full training package again.